Hello and welcome everyone. Our today's question is converge of all zeros in a binary matrix. Question is simple but question description is not very good. So for every zero we have to count how many neighbor ones are there. For this zero we can go up, left, right, up, down. So this is our first zero. On its left no ones are there. On its right we have one, then no up and down. So our answer on first case we have 0, then we add 1. For this 0 we have 1 and 2, so we'll add 2. For this 0 we have only 1, so we'll add 1. For this 0 we have no neighbor 1, and on the next 0 we have one neighbor which is 1. So on this 0 we have 1. So in total the answer is 6. So we have to find this. So the approach will be, for every 0 we have to count how many neighbor ones are there, and we can go left, right, up and down on this direction. So for left, for the right, up and down, we can go on these four directions, and if one is found then we will increment our answer variable. Let's jump into the coding part. So first we have to find n and m, matrix length, and m is equal to matrix 0 length. We have to traverse on every value. First left, then right, then up, then down, and we have to increment our answer. First check, is left means I minus 1, is it under the range? Yes, it is under the range. If it is, then we have to check if matrix of I minus 1 and j is equal to 1, means neighbor is 1, so we will increment our answer variable. For the right we will do same thing. This is for the right, and I plus 1 less than m. For up, oh, sorry, for left, then right, for up, this is up, and then we have down. Down means I plus 1 must be less than equal to n, and I plus 1. We have to check for every 0, and if 1 is found, matrix of ij is equal to 1, then we will go to the next index. Just continue. And at last we have to return our answer. Let's compile it. Let's submit it. If you are watching till now, just press the subscribe button. It will give me boost to continue this series, and we have successfully solved this question. And thank you all for watching this video.